details. So here the observatory, the person who is observing or who is doing research is far away from the sensing area, the area that is monitored, that is observed. It is an island, Great Duck Island, far away from the US land area, right? And there the sensors are deployed following this architecture. So the sensors for measuring, for observing micro environmental parameters are deployed in the form of patch networks, and each patch network is supported with a gateway, right? Such patch networks are eventually connected wirelessly to transit network, and that transit network is responsible for relaying the collected information to the base station on the land, and that base station will use the internet facility for staging the collected information in the universal site, right? And once the information is data repository is made available, right? Then the domain experts, namely the biological, right, scientists, right, they can carry out their research by processing this information. So that was the early or pioneering application that has changed the technology drastically, and this is very generalized. Nowadays, you want to deploy any wireless sensor network application, it has to follow this architecture, right? The area where you want to have this monitoring, right? There the sensor nodes are to be deployed either regularly or randomly. Regularly, then there will be a pattern, right? A pattern, I will show you another slide where this is quick access. Yeah, you can see here. So, for example, here you can see this is a grid structure, right? What you can see here, right? So in this, at the junction of, there is a small square. So at the corner, at every corner you place one sensor node. This is regular deployment. So there is a pattern, right? So one sensor node here, another here, another here. So this is done systematically and in a regular manner. There is a pattern, a regular polygon you can see in this, right? That is square. People call this as grid deployment, right? Then here also, here you can see the triangular, equilateral triangular, right? So at the vertex of each triangle, a sensor node is placed, right? So this is another way of regular deployment. And here you can see hexagon. 6 sides are there, right? Regular hexagon. So at the vertex, right, you will place one sensor node. So these are the, right? So you can see this is the point referring to this. A cluster of size 5 by 5, 1, 2, 3, 4. It is not even 5 by 5, 4 by 4. A sensor node, how many are there? 1, 2, 3, 4, 5. Yes, sorry, it's 5 by 5 only. You have to count the vertex, right? So it is 5 by 5. A sensor node is located in each intersection of lines. Same is the case here. 1, 2, right? 3, 4, 5. Right, so you can count, right, and you can see it can be a square, triangular, hexagonal placement. Sensor nodes also dictates the minimum sensing area that need to be covered by each sensor, right? What is the advantage of regular placement here? lot of planning is required. Another a priori, lot of design work is necessary. And the thing is, if you consider that as the demerit, like you cannot have immediate deployment, right? On the go, you cannot do it. On the fly, you cannot do it. But you need to have prior planning. That is you may consider that as a negative thing. But positive thing is the sensing. There won't be any void. Nowhere an area is left without sensing. Every area, in the sensing area, every point is covered uniformly. That is ensured by this, right? And if you take, this is the same thing, more elaborated, right? Yeah, and randomly distributed, right? Here I don't have any diagram for this, right? But the thing is, it is like sprinkling randomly. If you are walking in an area in the field where, right, and if you imagine a farmer sprinkling fertilizer in the field, some of you might have seen these things, right? In the field, a farmer will be sprinkling the fertilizer or sometimes seeds also, right? So then the advantage with this is so much of flexibility, right? You can randomly, on the fly, spontaneously, you can decide, you can make up your mind, and then you can sprinkle them, deploy them randomly. Sensor nodes, they take the positions on the ground, then they form a spontaneous network, ad hoc network. And here, mostly the nodes won't change their location, right? And the advantage with this is the flexibility. The disadvantage with this is there can be voids because the way you are sprinkling, you cannot ensure the uniformity, right? So there may be there is some nodes in some place, more nodes are densely deployed. In other area, they're sparingly deployed. Thereby, there is some void, there is some gap. The area is not sensed. So that non-uniformity will be there in case of random distribution, random placement. That is the point you should get, right? So with this, I am getting back, and this is another thing. Another way of placing. Probably for completeness, I will add this Voronoi diagram. Voronoi diagram, like here you can find lot of polygons here. Polygons of size minimum 3 and maximum any size, right? So where to place? Suppose the area it is like maybe rocky area or anything. There are some terrain constraints rather, and you have come out with the plan, the area, how it is looking. So once you prepare this diagram and where to place, here the thing is here. So in each closed polygon, you are placing only one sensor, right, at the center, right? And what is the property it is sharing? And between every two sensors, there is right equidistance line, or this is bisecting this line joining these two. Between every two sensors, there is the border, the polygon edge is bisecting the inter sensor distance, right? That is how it is done, right? So that way, this Voronoi diagram helps. Here, right? This is taken as a random deployment, right? Right. Or the other way, suppose once the nodes are deployed and then you want to check its coverage the other way. Yes, first the sensor nodes are placed, right? Now what is the coverage? You want to just decide. So between every two sensor nodes, you will draw a bisecting line, right? Then, so you have started with this. So bisecting line, and take these two bisecting line, take these two bisecting line, take these two bisecting line. Like that, you will arrive at the closed polygon, one after the another. Right? You keep on. So you, with respect, you take this. Right? You started with this one. What is the, how many neighbors it has got? One. So you draw a line. Right? You are not bothered about the corner ones, but the other ones, no. You will start and doing with that, no, you complete the entire sensing area. You will say it is like, no, how much area each sensor node is covering. So this node is covering this area. It is approximation, right? Theoretically, this is the area. So this is, and see this this covering area, this covering area, this covering area by these three sensor nodes are three different. Right, it's non-uniform. So this helps in understanding the non-uniform coverage of sensor nodes. Yeah, I don't have any direct mechanism to ensure your presence both physically and mentally in the lecture, because this is online in virtual mode. So I need your response. Is this clear?
Yes, sir, it's clear.
Yes, sir.
How about other students?
Sir. Yes, sir.
Okay, good. Yeah, any question? Anyone have some? Even simple doubts are also welcome. That makes me decide your understanding, gauge your understanding. Even small doubts. Anyone, please? No one? Then we shall continue. Yeah, so this is about placement. Right? We will come back to the design issues. We have, yesterday we could not discuss the design issues. So I mentioned these things, advantages of deployment, extended range, and fault tolerance, mobility, and the disadvantage with this is, it is all the disadvantage comes from the medium. The medium is wireless medium, and it the bandwidth is quite low. It is exposed to many communication issues, or you can say many interference parameters, right? So thereby the transmission is error prone, right? For example, if the weather is bad, transmission will be corrupt, will be faulty. If the sensors are placed in an area where there is geographical disadvantage, terrain or mountainous, rocky area. So because of the rocks which are uneven in the form of their size, height and width, so there won't be any uniformity in sensing. And because you are using the same media by by more number of sensor nodes, there is a very possibility of collision, potential collisions, while channel arbitration, right, when gaining the channel. So these are the disadvantages, right? The other things you must understand, right? Attribute-based addressing, right? What is that? Yeah, I will come back, don't worry. Yeah. Attribute-based addressing. This is already mentioned in the earlier class as data-centric approach, right? What does it mean? Let's say, imagine there are sensors. Each is having three types of sensors: temperature, pressure, volume, right? Or if it is weather, temperature, pressure, and humidity, right? So now how to address. Data-centric is, data addressing is fine, but now more specifically it is attribute-based addressing. For example, you say, all the nodes, you say you want to specify the query as, and as an ordered way, ordered, first parameter is the name of the attribute, second is its value, right? I'm in class, Baba. Why don't you go to her office downstairs?
Yes.
Please find out.
Actually, sir. Okay, fine.
Please. Yeah, I'm sorry. So attribute addressing. So temperature T comma 35 you write within parentheses T comma 35. What does it mean? All the sensor nodes where the temperature is greater than or equal to 35 degrees Celsius have to be activated or to be triggered. That is the thing. So attribute based addressing. So this is how you will be addressing the sensor nodes. Which nodes are to be triggered or to be activated? That is by sending this ordered pair. This ordered pair is communicated. T comma 35 or P comma 1. Pressure where it is greater than 1 atmospheric pressure, 1 unit. Right? What is the unit for pressure? Pascal. Right? Then similarly, volume or humidity or rainfall. Right? So typically, it is based on attribute addressing. Right? Yeah. 1 second, please. I will just instruct them. I'm sorry. So, yeah. So, yeah, that is attribute addressing. I hope you are clear. So, then location awareness, it is also mentioned. Right? It is like each and every sensor node is equipped with a technology like GPS. GPS is a proprietary technology of United States. Right? Then the sensor nodes should react immediately to drastic changes in their environment. Yes, so there is time constraint, right? Time limit, or is it timely, or against deadlines. For everything there is a deadline. Before the deadline, the sensor should react. Then query handling. Each and every sensor node should be equipped with the necessary processor capability and the query software capability. That is, it should be able to process the given query. So necessary algorithms or the code or the data structure should be with the sensor node. They must be loaded to receive the query and at its place. So that is query. Then because of these issues, because of these challenges, it is deployed in an ad hoc manner. What is the challenge here? Ad hoc deployment. Right? They should form a network. Spontaneous network forming is a challenge. Why it is not a challenge in conventional networks? There is some infrastructure. There is a concept called client server. Server is responsible for maintaining the topology for all the connections. But here we will take the responsibility. All our peers. There is no central authority. Mere small sensor nodes, their resources are very scarce, very limited battery power. They should form a network spontaneously. That is a challenge. Computational capabilities. Imagine you have your powerful desktop or workstation, or you may have powerful laptop, or you may have powerful smartphone. The all are relatively bigger. Form factor is many. What is the comparison? And the other resources scarce, extremely low, very low. Right times greater than 7 without losing accuracy. This is a challenge. You want to decide, you want to sense the parameter, process, and decide the conditions. But what about the accuracy? If you say more accuracy is needed, probably more energy is consumed. At the same time, you cannot give up the need for accuracy. You cannot say, I don't want accurate data. So you need to strike the balance, right? So without losing the accuracy, energy consumption, you can even say energy conservation. How carefully to use the limited energy of the sensor node. Why it is to be done carefully. Suppose if the energy is completely drained out, is consumed, that node is no longer live, it is dead. Because you cannot recharge it, you cannot replace its battery. So that node is to be considered as dead. So before a node dies, we have to use in a strategic manner, right? So carefully, cautiously, you should use the energy, right? That is the point. Right? So then scalability. I mentioned yesterday, scalability, we have proposed a concept for certain number of nodes. Like, say, you have proposed a data aggregation technique. So the nodes where you are able to maintain the clustering, nodes they form a group, then they very perfectly the communication is possible. If it is not giving, then we say it is not scalable. In case, yes, one protocol under consideration is scalable. That is, it works. So here the number of sensor nodes deploying sensing area may be of the order hundreds, thousands or more, and the routing scheme must be scalable enough to respond to events. That is where the scalability comes into picture. When there are limited number of sensor nodes, the proposed concepts are working fine, but if the network size is doubled or tripled, increased by many times, then if it is not giving acceptable performance, then it is no longer scalable. Right, then the communication range. Right, the bandwidth of wireless links connecting sensor nodes is often limited, hence constraining inter-sensor communication. So what it means is we should have energy efficient communication among the sensors. Energy efficient, energy conserving. Fault tolerance. Some sensor nodes may fail or be blocked due to lack of power, physical damage, or environmental interference. Some sensor nodes may fail, right, or be blocked due to lack of power, physical damage, or environmental interference. So I said yesterday, when you are deploying sprinkling from certain height and when they are taking the position on the ground, there may be a physical damage. It all depends on the area where you are deployed. If it is a terrain, rocky area, and because from a certain height you are deploying, there is every possibility of physical damage. Right, and they may take their positions near the magnetic field, so there might be interference. Right, and the drain, a particular sensor node sensor node's batteries quickly. So to be what bothers us, this is fault tolerance, reliability, right? fault tolerance, reliability, error handling, or failure handling, rather, right? So that is important. So how to deal with this? Right? Then the connectivity. And because when there is high density, connectivity is mostly interfering from each other. So how to ensure that, how to minimize that interference and how to have this interference-free transmission. So that is another challenge where, right? Then the transmission media. So I have already said the medium we are using is wireless medium, and it comes with all given set of problems. Wireless transmission, as it is exposed, and because it is unguided media, there is a lot of potentiality for a lot of problems. First thing is because of wireless communication fading, high error rate, right, and atmospheric effects. Bad weather will also play a crucial role. But if it is guided media, if the signal is going through a cable, its weather or fading won't come into play, right? So transmission media, how to deal with this, right? Then the next thing is quality of service. OS, right? And in case of military, quality of service gets provided because of security reasons, because of the criticality of the application. Some sensor node is deploying that there is not correctly reporting. Say if there are 1,000 or 100 terrorists are infiltration, right? So they are crossing the border, but then sensor nodes are reporting that only 2 or 3 are infiltration, right? Are crossing the border. Then it's wrong data, so wrong action is inserted. Probably number of soldiers that are sent to deal with them may be less, but if there are 100, you may be, right, soldiers. So it is criticality. Civilian application, people will pay money for the application, so they expect value for the money, quality of service. So value added services, value added applications, that comes into play. So there we need to we need to ensure the quality of service of the selected application or the given application. Control overhead. Fine, you can propose very nice protocol. You say you do that, it works correctly, but what is the overhead? Control overhead is outweighing the data overhead, then the protocol is not worth considering. Because it is like, when you want to send money to your friend or your father wants to send money to you, he related services is paying 100 rupees. It doesn't the actual data. Security. Besides physical security, both authentication and encryption should be feasible while complex algorithm needs to be avoided. So security, nevertheless, security is the ultimate. You cannot just deploy a network and forget about it. Because you may say, why only in wireless sensor network, right? In every network, there is security problem. Our security is the big concern. But in case of wireless sensor network, it is even higher. Why? Usually the sensor network that is deployed for a particular application, such as surveillance, is not attended. Physically, there won't be any security, physical security, human security. There won't be manpower safeguarding that area. It is open, right, unattended. Because probably you want to spy, right? When you want to carry out the spying operation on the enemy, right? You cannot employ human there to safeguard the network. It is to be unattended. by the human. So network is just deployed there. So then what about security? So what type of security problem you can expect here? First thing is intrusion can happen. That is, network is there, you are going very close to it and you are intruding in the network, not physically. So electronically you are attack, right? That is external attack. It is even possible to have internal attack. What is that? You go into the area where the network is deployed, you pick up a particular sensor node and then change its logic. It is programmed, right, with the necessary software. Now, using your own technology, you want to reprogram it. Yes, when you reprogram it, it works maliciously. It is not working as expected, as designed. So when something is deviation from the design, from the expected behavior, it is an attack. It is an hacking attempt, right? So this is what we mean by security. So you need to ensure both internal security and external security. That is the ultimate thing. So authentication. When some node is attempting to access the network, so first thing you should verify whether the authenticity is there or not. Then, and to ensure the end-to-end security, it is better you have encryption so that someone taps the signal or the data that is being sent by sensor node. Because you are using encryption, it is not easy to break the encryption and get the original information. They may be able to snoop on the channel. They may be able to record your communication, but that is in encrypted form. So you need to spend a lot of time. By the time you crack that encryption, the value of application is lost. For example, right, if military people are sharing the data for attack, so let us say in another 10 minutes they are planning an attack, and some enemy soldier has obtained this data secretly and they have spent about 1 hour to decode it. But before that, the attack took place. So it is of no use, right? So that is what I mean by security, right? So here security is a very, very big topic. Now the reason is security is a big topic, right? In future also you can take your specializations based on security, right? So then one second, I will have a glass of water. Yeah, so let's continue. Please remember, this subject is mostly theoretical. I'm sure you maintaining the interest in the subject is not that easy task, but only best way is even you get a small doubt, you raise it. That's how you can sustain, you can maintain your interest in subject, right? Otherwise, no, soon your interest is dead because you are feeling lazy or sleepy, or eventually you become uninterested in the subject, right? So one has to be active in the session. So active participation, not passive participation. If I say, do you understand it? Yes, sir. That's not the way. Do you understand? No, sir. I could not follow this scalability. I could not follow this point. Like that, right? Genuinely, you should be interested in the subject, and accordingly, you should raise the doubt, right? So that is important. Yeah. So now, another thing is how to be energy consciousness, right? So this is the theory behind this. So one thing is organizing the network hierarchically, like no, if you take our JNTU campus, there are 1,000 students, let us say, and how to manage these 1,000 students, maybe they request, so there is some hierarchy. These students, there is a hierarchy. The students of computer science and engineering, they form one cluster. And for that cluster, there is one head, department HOD, right? So, and there are such departments, mechanical, civil, mechanical, electrical, electronics, computer science, chemical, MBA, so many departments. So each department has got one HOD. So all these clusters, they form one more cluster called main cluster. That is what is a college. College will have college head as principal. Right now, what is the hierarchy? College head. If you keep that as the root of the tree, and the children of this root are each department, right? There are 7 engineering departments plus service departments, some 3 or 4, right? So then, and in each department, so many courses: 4-year program, 5-year program, right? UG program, PG program, PhD program. So you will maintain so many such entities, right? So for energy consumption, the sensor network should be organized hierarchically. You can say as a tree structure, right? So that is how. So here, why we are doing this? By way of this clustering or hierarchical arrangement, 2 things are achieved. One is scalability. You can achieve scalability. Second thing is you can achieve energy efficiency. Efficiency by way of effective communication. Right? So now here, these nodes are at low level, at leaf level. Right? These are leaf. These are in this area, there are 4 sensors. Right? Sensor 1, 2, 3, 4. Among these, one node is made as cluster head. Let's say this center one, CH1, cluster head 1. Now, in another area, neighboring area, there are 5 sensor nodes: 1, 2, 3, 4, 5. And among these, they have formed a cluster. Among them, the center one is elected as head, cluster head 2, CH2. Similarly, CH3, CH4. Now, these 4 cluster heads are treated as one more cluster, and above that there is the root node, or you can say your sink or base station, right? So with this node, you can achieve energy conservation, right? So we'll see that. So this is what this completes the design issues. What are the design issues? Right? Design issues are attribute addressing, location awareness, query handling, and the routing layer issues. Right? Ad hoc deployment. Ad hoc deployment means, what is the issue here? So it is like the spontaneity. Once the sensor nodes are deployed in the sensing area, they should form a network. That is the challenge. Self-organization, you can say. Scarce resources. Resources are very limited. You cannot compare with your desktop, workstation, laptop, or phone, smartphone. So, given that strict limitation, how do we run the algorithm or an application, software? Right, that is a challenge. So energy consumption without losing accuracy, right? So energy conservation is to be ensured. At the same time, you cannot compromise with, poor accuracy, right? Weak accuracy. So you don't want to lose the accuracy. right? Scalability, communication range, fault tolerance and connectivity, transmission media, quality of service, control overhead and security. These are the design issues. You can easily remember first thing is scalability, next thing is energy conservation, next thing is security, right? Like that you should easily remember. And the problems with media, transmission media, attribute addressing, right? So like that you should be able to explain, right, the design issues. Yeah, next. We have also discussed about the placement. It can be either random or regular, right? Yeah, so that completes the first part. Other applications also I have mentioned yesterday. Body area network, I have not explained. What is body area network? And here body means human body. So on the human body, who is considered to be a patient or a chronic patient, a patient suffering with chronic disease. For a long time, like sugar, blood pressure, the sugar means diabetes, high pressure, high, right? Patient, right? So they are under a constant, they should be under constant vigil and monitoring by the family doctor. So what is done on the body of the patient, all the health parameters are deployed. Near to the heart, what sensor you will deploy? It is ECG you will deploy. Near heart, again, you may even launch audio which will record the rhythm, sound rhythm of heartbeat. Similarly, for temperature, blood pressure, and for blood itself, right? To measure the glucose levels, diabetic patient, right? So like that, over the entire body, the health sensors are deployed. So now these nodes should form a network, and probably there is a smartphone in the hand or in the pocket of the patient. That should act as a gateway. Gateway, all the information is to be submitted by sensor nodes directly to the, or directly or indirectly. Because it all depends. Human body, you consider it as a low range personal area network. So there, each and every sensor node can directly communicate with the base station that is uses smartphone, right? So then other things will come into play. If you imagine, if you recollect the wireless sensor network architecture, right? So in the body area network is smartphone, your smartphone is like the gateway. Then you should, that should communicate, that should connect with the conventional networks, that is internet, right? Yeah, so this is the body area network. So sensors are deployed all over the body and they form a smart area network, and any information that is detected, right, is reported via smartphone, which is acting as a base station or a sink to the external world. This is BAN, body area network. What are the technologies here? You may use Bluetooth, Zigbee, right? For this is based on ISM band, right? Industry, science and management band, which is free. Otherwise, other part of the spectrum is chargeable, but GSM band, not GSM. It is ISM, right? Industry, science and management. ISM band. Which is Bluetooth, right? So that way you can use the technology and make body area network operational, right? So that is the thing. Yeah. So other things, no. Yeah, and this also we'll see. So let's have the recap of the differences between wireless sensor network and MANETs. The number of nodes in a sensor network can be many orders, many times, right? Several orders of magnitude higher than the nodes in ad hoc network. That is the striking difference. And first of all, 1 second, please. So I'm sorry, we'll close in another 5 minutes, right? So the differences is very important. So number, first thing is size of the network. Size of a wireless sensor network is many times higher than MANET. Sensor nodes are densely deployed in wireless sensor network, but that is not the case with MANETs. Sensor nodes have, compared to MANETs, no very limited power, very limited computational capacities and memory, and even bandwidth. Sensor nodes are prone to failures, of course. Even MANETs, ad hoc networks are not prone to failures, but because of the battery drain out, they may not be able to communicate, right? They may get disconnected. So sensor nodes are prone to failures, whereas mobile hosts are prone for disconnections, you can say like that. The topology of sensor network changes frequently because of these failures. And because of the mobility, the topology of MANET changes dynamically. That is that thing. Sensor nodes use broadcast mostly. Same is the case with, right? Whereas MANETs use point-to-point, right, communication. Right here, P2P means point-to-point. Communication is, when you talk about communication, it is point-to-point. And when you say network architecture, it is peer-to-peer, you can say. That is how you use the abbreviation in two ways. And sensor nodes don't have global ID, but they only have local IDs, right? Whereas MANETs, each and every sensor node will have a global identity, that is like IP address. That with that, you can identify uniquely wherever it is there on the globe, right? So that is what we could discuss now. Anyway, we'll meet in the afternoon at 3 o'clock, right? So 3 o'clock we'll meet for at least for some time. Up to 3:45 we'll be able to meet, right? So, and if you don't have class from 2, then we can start from 2:30. Anyone here can respond? Charisma, are you there? Charisma, unmute and respond. Charisma, any other student who can respond? You have the class from 2 to 3,
Yeah, we have
from
class.
2 to 3.
Yes, sir.
Then we'll meet from 3 to 3:30. At least half an hour we'll discuss. 30 minutes or 40 minutes we'll discuss.
Okay, sir.
CR is not there. So we are meeting again at 3 o'clock. Right? So you have any doubt now? Anyone have a doubt? Please remember, this is a theoretical subject. Every possibility of getting lost, right? So you have to keep active and read the textbook regularly, right? Any questions, please? So if there are no questions, right? Right, if there are no questions. Yeah, thank you. We'll meet in the afternoon. So all of you, please close your connection. Thank you. Right? We'll meet again. Bye.